Okay, so verifying trig identities. So what they are is they're basically like proofs. They're going to be proofs. You're going to leave one side alone, not like a 2-column proof. Like they're just going to be, you leave one side alone and prove to me that the other side is what it's said to be, right? And so we just have to manipulate and show our steps as we go. And like any of our math problems we do, if you do any kind of thinking or have to do any kind of manipulation, do it off to the side, clearly designate yourself thinking space. Do not get it confused with the problem, right? Because you'll be graded wrong instantly. So make sure anyone that wants full points on the test hearing me, I will use the term Martian math, right? So 4 different people could do it different ways and all be correct. It just happens to be how you do it and what process you use. Now, I will have to, the answer is always going to equal the answer, always. I just go through and I look at your steps. So here's a common mistake, just one form of Martian math, right? So let's do sine of, do not write it down, I'm going to delete it. So sine of x plus cosine of x squared is sine squared of x plus cosine squared of x. Martian math, not math on this planet. That is not true. What's really true is sine squared plus 2 sine cosine plus cosine squared. That's the binomial squared. So what you have to do is you have to be meticulous about your algebraic manipulations. And if you have to go think about that off to the side, that's fine. But just be very, very careful. So I'm going to be looking for, you've got to get the answer in a correct approach. All right, so be careful. Now, you can write things off to the side. Okay, I replaced Pythagorean identity. If that helps you learn, that's probably a good idea. So let me give you a start off. So you are going to verify. So your instruction would be verify. And what you are to verify is secant squared, let's use alpha, plus minus, secant squared alpha minus 1 over secant squared is equal to sine squared. So, and these are frustrating because a lot of them, you know, maybe a doctoral student getting their PhD did a temporary job and they had to create some identities, and they all start off, we'll do it later in the unit, they'll start off with sine squared equals sine squared, and then they'll multiply it by 1. But what they'll multiply it by is tangent squared over tangent squared. And then they'll add secant squared and subtract secant squared. But then they manipulate the things they did, and then they turn it into a big old mess, and they hand it to you on a plate and say, put it back. So that's what this situation is. The result, the left side, is going to equal sine squared. We've just got to put it back there, right? So it's how you do it. And already, when I look at this, I can see 2 different ways to start this. And maybe more, but for now, I can see, and that's not the right green. I can see possibly I could use my algebra 1 skills. Jason, the board's this way. There you go, please. I could see this could be broken up and that could be broken up. I could rewrite it like that. That is definitely a way to go. I probably wouldn't do that on this case. No reason why you couldn't. The reason I see, this is me thinking over here. This is me thinking. That's my thinking box. I see on the left, I see one term. And I see, the other thing I see is my numerator has a squared trig function and a 1. right? So what I'm thinking is, remember last week, squared trig functions and ones. Those are some kind of Pythagorean replacement. And a Pythagorean can take two terms and shrink it down into one term. Sine squared plus cosine squared. What's that equal to? Sine squared plus cosine squared. One. 3-day coma. See, we're in it. So sine squared. So I can get two terms down into one. And look on my right side, I've got one term. It's kind of like this is kind of like chess. You have to know the moves of the players, of the pieces, and you have to be able to kind of think ahead, right? And having your formula sheet is great, but you thinking about them getting there is half the battle. And like I said, this was my least favorite thing, but you just have to make friends with it and you have to see the tricks along the way. So I would start that because I want one term and I can see a Pythagorean. So one term Pythagorean, that's giving me my clue. So I don't know where it's going, so let's just go ahead and do that. So secant squared minus 1, right? I could pull out my sheet, but I know that secant squared is in the Pythagorean 1 plus tangent squared, right? So you could be looking at your sheet. That's all right. But here I'm back in my thinking box. I know that secant squared is in my 1 plus tangent squared. I know that secant squared is in my 1 plus tangent squared Pythagorean. So I wonder, so look at it for a second with me. I wonder how I could get that 1 away from the tangent squared and put it over with the secant squared. I could subtract it, right? So subtracting 1 just leaves me tangent squared. Subtracting 1 gives me secant squared minus 1, which is the perfect quantity I need. You're looking to manipulate. These are all known replacements. These are all known. You can use them whenever you want. So you need to make them into what you have. So you can do in your thinking box, you can move them around, you can do whatever you need. So I'm going to then replace that. I'm going to make that replacement right now. So I know that secant squared minus 1 is tangent squared. So wherever I see 1, I can write the other. Oh, I used an X. Whoops, that's not the angle, it's an alpha. Okay, my next clue is the answer's written in sine. So I probably want to turn the other side into sines and cosines. So let's just do that and see what happens. So tangent squared is sine squared over cosine squared. Oh, what? Oh, yes. Thank you. No, good eye. That would have made no sense whatsoever. Very good. If those angles would have been different, that would have been a different animal altogether. All right. So, no, same angle. I actually give you one later. Oh, you'll see it. Right, the secant squared, no, that entire red quantity there, secant squared minus 1, it is worth tangent squared. If you put both of those functions in your calculator, they'd be the same exact function. Okay, they just look different. Like one, dressed up for dinner and, going to a movie or something. I guess you could do dinner and movie, but that's besides the point, right? So now my left side is sine squared over cosine squared. And it's being, so make sure you can hear my words, it's being divided by secant squared, and you and I know that's 1 over cosine squared. So if it's being divided by 1 over cosine squared, it's being multiplied by the reciprocal of that, which is cosine squared over 1, which we can just write as cosine squared. Think we can see it yet? Is the left the right? Oh, yes, right. If you couldn't see that, I'd be watching out for traffic when I walk in the road if I were you. So there's a bus coming right here. Boom. Get that rid of that. Right? So sine squared. Don't want to get run over. Okay. So you're done. You verified the identity. The left side equaled the right side. We will do one more, and then I will stop the video, and we'll do a couple of little ones. We'll just practice. So the next one is another common practice of things to notice here. 2 terms, 1 term again. Your denominators there are both factors of a conjugate pair, right? So let's just put this off to the side, and I'm going to delete it, but wherever you want, you've got a conjugate pair. That's our A plus B times A minus B. We've seen that a ton. We use that a lot. That's, we use that to make you rationalize your denominator. You make i's drop out. We use it a bunch with trig factoring. So now we know that's always going to be a squared minus b squared. Well, what that means is 1 squared minus sine squared. So you start seeing ahead, 1 minus sine squared, that's going to be a Pythagorean. A 1 minus sine squared can be replaced with a Pythagorean identity. So start looking for those patterns. So at least start trying to think ahead. It really will help you. So let's just go along, and if nothing else, just do something right and see what you can make of it. Just start something. But let's try and combine those fractions. To combine the fractions, 4th grade says we need common denominators. So let's do that. So this is not a necessary step, but just for lecture, I'm going to multiply the left term by 1 plus sine of u over 1 plus sine of u. How much is 1 plus sine of u divided by 1 plus sine of u? 1. 1 times anything's itself, right? So we can do that. So then we're going to multiply that to the first term. Like I say, if you want to do this, you can, but it's not required. It just assumed. And then I'm going to multiply by the other common denominator factor we need. So this is going to be multiplied by 1 minus sine of u over 1 minus sine of u. So bringing that other side along for the ride. So let's go ahead and multiply it out and see what we've got. So in this case, it's a nice easy one. 1 times a binomial. So 1 times 1 plus sine of u is just going to be 1 plus the sine of u. And that's all over the denominator 1 plus sine of u, 1 minus sine of u. If I can see legit steps in, you don't have to show this, right? So just busy work and showing, that's unnecessary. But for purposes, I'm showing everything. Then I'm going to combine my other terms. So I've got 1 minus sine of u, all over common denominator 1 plus sine of u, times 1 minus sine of u. So, I mean, I could do it again, but hopefully you're with me. That the denominator is 1 minus sine squared, right? When I multiply that out, that's an a plus b and a minus b. That's a conjugate pair being multiplied. Those are factors of a conjugate pair. So that becomes 1 minus sine squared of u. And you could even make a replacement now if you wanted to, but it's fine. Now, in the numerator, I've got a 1 plus a 1, so 2. Then I've got a sine of u minus a sine of u. Well, that's 0. So that's just gone. So now it's starting to look better. See what we can do. So here's my, at this stage, I'll start drawing this on the board every now and again. So here's a handle. Okay, what's that? It's a bell. Very good. And this, what's this one? It's a flag. And not only is it a flag, it's a red flag. So when you see squared trig ratios and ones, I'll be saying there are bells ringing and flags waving in this room right now. What is going on? Those are identities that need to be taken care of, right? Bells are ringing, flags are waving. So we've got 2 over cosine squared. Oh, u, not theta. Now, it probably goes without say, but I shouldn't assume. 2 over cosine squared is the same thing as saying 2 times 1 over cosine squared. And cosine squared, 1 over cosine squared, is the same thing as saying secant squared. So identities have been verified. So have a quick look at it. So what did? We saw 2 terms, unlike denominators. So we made a common denominator and we put them together. We multiplied by 1, multiplied each term by 1, which happened to be the other prime factor over itself, blah, 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 all the way through. Did our adding fractions, combined, simplified, blah, 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 made our Pythagorean replacement, rewrote using the associative property, and then we finished up. Okay. I sent you out in Remind 3 problems. You might need more than those 3. Bare minimum. You need to do those 3 in the next 24 hours. Right? I can't be there to watch you, but if you want success, just keep doing them, seeing the same little things show up again and again, thinking your way through them, is how you're going to do it. This unit test is uncrammable. You just can't gain all of the experience at the very last minute. You just can't do it. Okay. So I sent those out to you. I'll make a key and I'll send that out to you as soon as I can. Let's go ahead. You march through. I will stop the video.